Yeah, so I'm really excited to give this talk. Again, my name's Colin Carroll. I'm a data scientist and open source software developer. Most notably, I spent a lot of time on the PyMC3 project, which is a Python library for doing cutting-edge statistical inference. So most of my talks are actually about statistics, and this is a little weird and exciting for me, so it's going to be my first talk on tooling and workflow. So here we go, but if you want to talk statistics afterwards, that would also be really fun. I think there are a lot of statisticians here. Great, so this is actually a really simple talk. There's sort of two lines that I want people to be using in their workflow after this. It's sort of involved with a tiny library I wrote. And in order to get you to write those two lines, I need to convince you of just two things. One of them is that Jupyter libraries are great, and sort of by your being here, I assume you're already into that. And another one is that you should be doing all of your Python work in isolated environments. So sort of through all this, I'm going to try to show you how I work on both big projects and small projects. I'm going to start off showing you how you might use an isolated environment to work on a larger project. This might be your company code base. This might be a large open source project. And then I'm going to conclude by showing how you might start building a small project, just some weekend thing, using an isolated environment in Jupyter. Great. So first, I really want to make sort of a caricature of what your life is like right now. So you've probably got just a single Python environment somewhere. It might be Python 2.7 because someone somewhere doesn't like you that much. You've got every package you've ever used installed on it. The version that you've got installed is whatever was available when you first installed it. And there are about 8 Jupyter notebooks running on your machine, right? So whenever you're going to try to find a project, you go to localhost 8888, then 8889, and you sort of scroll up until you find all the right stuff. Also, probably, especially if you're using a Mac, it'll always sound like your computer is trying to take flight and go off somewhere. Yeah, and things running the second time you go to them is mostly a matter of luck rather than a matter of design. So there's a better way, and this is the tiny library I wrote. It's called Callisto to take some of the boilerplate away from doing this better. Following the idea of using sort of the latest and greatest, I'm using Python 3.6 here, and I'm also using Jupyter Lab instead of Jupyter. Who's already started using Jupyter Lab? I know it's pretty recent. Wow, OK, so a lot of people. Those of you who aren't, this can be sort of an advertisement. I found the transition seamless. I just used Jupyter Lab instead. I still get to go to localhost 8888. So this is a clean install. So notice that Python 3 is the only kernel available. And I also want to point out that since this is opinionated, I just keep a single directory in my home folder called notebooks, and whenever my computer restarts, a tmux session starts up there and runs this Jupyter Lab server. So there's always just one running. It's always in the same directory, and that's just where all my notebooks live. I'm going to show you how to make that work with sort of your other development work, which might be on larger code bases. Also, just sort of an interesting note, the library I'm going to be using today is called Callisto, and you can pip install Callisto. If you make a small typo, you'll actually get Doug Brand's library, which is also called Callisto, but spelled differently. It's a moon of Jupyter, so I suppose it's not that surprising that 2 of us used it. But yeah, so popular name for libraries. So here I am using Callisto to start working on a larger project. This is PyMC3. You can tell that I'm already in a virtual environment. It's called PyMC3 3.6. I keep that the last 2 numbers on there so I know what version of Python I'm using in that virtual environment. And these are the 2 lines I want you to remember. It's pip install Callisto, and then you just type in Callisto. I'm adding this -p flag with $pwd that tells it to add the current directory to the Python path. And that's going to be a useful thing for just keeping my Jupyter notebook running in a single directory. OK, so once you run that, it tells you a lot of stuff. But what did it actually do? When I go and reload my Jupyter Lab server, I'm going to have a new kernel. and it's going to have the exact same name as the virtual environment I was in. There are a couple other things that it does. You can pass a different name, you can delete environments, but this is really all I use it for. So you pip install Callisto, then type in Callisto. Now I can start a new notebook with that kernel. And since I updated that Python path, this was the -p that I added, I can import from the project. So this is not actually a script that's in PyMC3. It's a script that I added to my local copy of PyMC3. This script isn't that useful for statistical inference, but it makes me feel good about myself, and so it might be the first thing I want to import when I'm working on the library. So this is the big takeaway from this talk. This is sort of just an opening demo to show you this. I'm going to go through and talk a little bit more about virtual environments, but run these 2 lines for a project that you're working on. You can even pip uninstall it afterwards if you don't want it busying up your requirements. And I'm not going to go over exactly how it does what it does, but it does such a simple thing that this output is mostly all that it does. So it finds the right place to write down this JSON blob. That down there is the right place. So you can go open that file up and edit it to your heart's content. And that's it. So it does some stuff with figuring out where the JSON goes. It does some stuff with figuring out what the JSON should look like. I did not realize until I heard the talk this morning what magic it was that this just kept on working with Jupyter Lab as well as with the Jupyter Notebook, but that's been really pleasant that it does. And there's also certainly a blessed way to do this that comes with IPyKernel. Callisto actually uses IPyKernel to run all this. I copied this from the documentation. This is certainly a more powerful command to use if you do have some custom things that you want to do. All Callisto is doing is getting rid of some of the boilerplate for this. It works well with Conda environments as well as with virtual environments. So this is the blessed way to work with Conda environments. There's a different command that you'd want to use for virtual environments. Cool. Is that good so far? Sort of an opening sales pitch for a free tool. So I want to step back and talk through a little bit the virtual environment landscape. So who uses virtual environments pretty often? Cool. So a fair amount of people. In that case, this will also be an interesting just sort of overview of the landscape. Those of you who aren't, sort of the goal of isolating your environments, there are a lot of different tools for doing this, but all of them sort of try to solve the problem of you have multiple projects that might have different requirements each. The requirements might have different versions, and the projects might even have different versions of Python that you work on. So the last 2 startups I've worked at have both used Python 2.7. Just that was a choice that they made when they started. Even though Python 3 is, I think, probably the more popular choice these days for new projects. Certainly when I start new projects, I use Python 3. This means in a given day, I'll probably use 3 different versions of Python. At the very least, PyMC3 is tested on Python 2.7, 3.5, and 3.6. In June, 3.7 will be coming out, and so we'll probably add that and eventually get rid of 3.5. And so it's useful or essential to be able to switch between these easily and quickly, and to be able to make sure that if a project worked a week ago, it should be able to work again today. And a solution to doing that are these virtual environment libraries. Probably the most common one is just called virtualenv. I was actually surprised that this is not in the standard library. You do have to pip install this. So the workflow that goes through this is you have some installation of Python on your system. You use Python to install pip. Pip has only come with Python since like 2.7.9, 3.5, I think. You used to have to run a crazy base64 encoded zip file from the internet to install pip, which made everyone feel really bad. But now you use Python, you install pip, you use pip to install virtualenv, and then you can use virtualenv to start creating new environments. It can be a little confusing what version of Python your virtualenv is tied to. So you can use little tricks like python-m virtualenv or something. But it's a good tool. In the scientific world, Conda is quite popular. The philosophy of Conda seems closer to that of a general package manager, so it can install non-Python tools as well as Python tools. It will also install Python, And this can be somewhat counterintuitive. So for running the test suite on PyMC3, we actually download mini Conda 3, which is like a minimal version of Conda built with Python 3. And we use mini Conda 3 to actually build the Python 2 environment that is going to be used to run the unit test. It also uses it to build the 3.5 and the 3.6 versions. So it's, this took a lot of double checking and making sure we are actually running Python 2, even though we were downloading mini Conda 3. But yeah, so here you're getting Conda, then you're using Conda to create both the Python binary and all the requirements inside the virtual environment. Another feature of Conda that I'll point out, this is also being worked on by like the PyPI devs and for virtualenv, is there's some desire to want to install Python packages from places that is not PyPI. So when you pip install something, it'll go look at the Python package index, and it'll download it from there. But if you're at a company, say, maybe you're maintaining a fork of requests, and you'd rather have your company's version of requests. And so how can you do that? Or you might think that it'd be neat to have just a bunch of your own libraries living on your own server, and you don't necessarily want to release them onto PyPI to be able to install them from anywhere. And so somehow you want to be able to tell your virtual environment manager which place to look to install all these libraries. And so Conda makes that easy. So the anvil down here is actually the logo for Conda Forge, which is an open source repository for hosting scientific software. PyMC3 is actually distributed through Conda Forge as well as through PyPI. But you have to tell Conda to look at Conda Forge if you want to be able to use that as well. And you can tell it which order to look at things in. Anyways, I just think that's sort of come up a lot recently, has been, boy, I've got my own version of this library, and I'd rather use that than this other version that's on PyPI. Or maybe I've just got a secret library that I don't want anyone else to use, but I want to be able to pip install it on different machines. And this is one way of doing it. I'm also going to mention pyenv. So pyenv is actually a fork of a Ruby project called rbyenv, and it lets you easily install and destroy Python versions. So this sort of helps with, I was saying before, virtualenv is tied to a specific version of Python. You use that version of Python to install virtualenv, and then you use that to create virtual environments. Pyenv makes it easy to switch between versions of Python. So you can install Python 3.6, then use that to get virtualenv, and then create your virtual environments there. It's really useful. It gets new versions of Python very quick. I think it's already got some of the release candidates for 3.7 in pyenv, so you can just go and install them a day or two after the binaries are released. And the last one I'm going to mention is pipenv, which is a new project from Kenneth Reitz, who you might have heard of from requests. I think it's like the second most downloaded library on PyPI. But pipenv is quite new. I haven't personally built a project with it. I've seen Open Elections, which is a wonderful data project to collect precinct level results from all the recent elections. They build all their stuff with pipenv, and it seems super easy. So that definitely seems worth a look. And Kenneth Reitz has built some beautiful libraries in the past. I also want to put this up, which I sort of built for my own notes for this, but I thought might be interesting for people here. This is like just a history of creating isolated environments in Python. It was the earliest mention of doing this I could find was from 2006. And Ian Bicking had a blog post that linked to just a raw Python script called virtual-python.py. And a week later, he had already edited it and changed it to working-env.py, which he also posted on the blog. Sometime over the course of that year, it lost the dash. The working got turned into a capital W. And a year later, Doug Hellman published a blog post called "Working-env is dead. Long live virtualenv." And so this was the start of virtualenv, and Doug Hellman, I believe, is still contributing to virtualenv. So that's 11 years later. I think he also, the blog post is much more friendly than the title makes it sound. I think he talked to Ian Bicking, and everyone was pretty cool with using virtualenv instead. Yeah, so you can see sort of from here, so virtualenv wrapper, this is sort of something to make virtualenv a little more user-friendly. It also included a tool called workon, so that you could just type workon and then the name of your project, and it would jump you to a directory and put you in the virtual environment. It's very nice. You can see here 2011, RBM was released. This was sort of in the middle of the Ruby on Rails wildness, which I guess continues to this day. But then PyEnv, surprisingly, was forked right from RBM a few years later, and so that wasn't even a Python project. Also surprising to me, has anyone used, so in Python 3.3, they released venv along with the binary pyvenv. And these are nothing that I've ever used, but it's in the standard library, and it's made for essentially doing virtual envs. But I'd be interested if anyone's used that to hear about their experience afterwards. Because in fact, pyvenv was deprecated just last year with the release of Python 3.6. So don't use pyvenv anymore if you haven't been using it yet. And just last year, just after venv was released, Conda was released, and just last year, pipenv was released. So right, Python's just about to release 3.7, but pipenv, after a year, is on version 11 point something. At least it was a week ago when I was making this. I wouldn't be surprised if it's already on 12. So this is just sort of a timeline, give you an idea of the space. I'm going to be opinionated here. I use Conda. Until about a year ago, I was using PyEnv, and both of them are wonderful tools. And I'll also mention for using this workflow, it's helpful especially if you're going to switch from something like PyEnv to something like Conda. I just keep 3 bash aliases in my bash RC, and this makes it easy to create and destroy virtual environments. So if I type in vn, it creates a new virtual environment, va activates a virtual environment, and vd deactivates a virtual environment. I can share what those aliases do, but it should be pretty easy with whatever your current workflow is to just, we all type in the same thing repeatedly, but it's really nice to be able to just type in 2 letters and get your virtual environment set up and activated. So right now, these all point to Conda environments. Last year, they pointed to PyEnv instructions. Great. So I want to spend the end of my time talking about how you might start a small project with some of these tools and some of these workflows. This is a photo of Callisto, the moon, just for the naming of this. There's also a small library called Carpo, which is another moon of Jupiter. You can't name anything Io, which is another of the Galilean moons, because it's already in the standard library. But hopefully, there are about 70 of them, and most of them are not. Most of them are valid Python library names, so we can slowly work through them and start naming libraries like that. And before I go on, any other questions about stuff that's happened yet? The mid-talk questions are often more productive with statistics talks. Cool. Cool, so the project we're going to build is a small prime number script. And so you can see up here, making a directory using that vn command to create a new project. For those of you who haven't used Conda, this is what it looks like to make a new Conda project. And we're proceeding through all this stuff. This is funny because it plays up here, but not down here. So I activate the environment with VA. I pip install Callisto. It installs a lot of things because it does need to install Jupyter to make sure that you can run this Jupyter kernel. And that has a lot of requirements. Then I just run this Callisto-p pwd. And I'm all set up for my new project that's called Primes. So notice I haven't written any code yet. This has all been boilerplate so far. But this has been about 5 lines of code. It runs pretty quickly. It's a quick, easy way of starting a new project and being able to start working on it in Jupyter. So now I go and I open up my Jupyter Lab, which is always open because that's how I set my computer up. Notice I've got a new kernel for this project. It's called Primes 3.6. And so now I can start a new notebook isolated from all the other projects. And notice that also PyMC3 is still there. I could easily have one tab that's running in PyMC3, one tab that's running in Primes. They would be isolated from each other. That's a really nice feature of being able to do all this. Actually, one problem that I've started running into is that I've got too many kernels now. Jupyter Lab has largely solved this because they'll do 2 rows of it. But in the old Jupyter notebooks, I was having to scroll on the menu to get down to the right kernels because there are just a lot of virtual environments going on. OK, so I'm going to start working on my primes library. This is actually, I've used this as sort of like a FizzBuzz interview question for data scientists. Right, it feels sort of numeric, but it's really just using loops and if statements. So remember, a prime number means that it's only divisible by itself and 1. But 1 is not prime. That would break the prime number theorem, that you can factor numbers uniquely into a product of primes. But if 1 was prime, you could just keep multiplying it by 1, and it wouldn't be unique anymore. So that's just a nice mathematical definition. But yeah, so this checks whether a number is prime. And underneath in the second square, I've just got a reasonable check to make sure everything's correct. From asking and working with this question a lot, I know that 2 common places where people's implementations fail is 1 and 25. 25 is actually because there's an optimization where you only check divisors up to the square root of a number. And since Python's range is non-inclusive on the right-hand side, people often forget to check the square root of a number. And so 25, I guess 9 would also work, but 25 is sort of the first like, non-trivial example where that might fail. So I make sure that my check includes those 2. But now we've got some code that works. So I can move the top bit to be a function in my new primes library. I can move the bottom bit to be a test for my new primes library. And I can just pop open an interpreter. I copy-paste primes over into primes.py. I copy-paste the test over into testprimes.py. This test file will run great under PyTest. It'll run great under nose, which you shouldn't use because it's deprecated. You can use nose too. But this is a fine start to my library. We've even got 100% coverage going on right now. So remember when we started this with Callisto, we used that -p flag to add the Python path? This means I can go back to my Jupyter notebook. I can import isPrime from this file that I just made, and I can start using it in the Jupyter notebook. So I can move on with my development of the library. And so just to show one more sort of level of this, because eventually on every project you're going to want to start using other requirements. So I can go back into the terminal. I can install NumPy into this virtual environment, this Conda environment, really. And then I can start using NumPy in my implementation. So my first implementation, I was hoping everyone would look at it and say, gosh, I could do better than that. The second implementation, I'd actually be interested if anyone can do better than that. It's quite fast. So on this machine, I can check all the primes up to 100 million in about 2 seconds. So it's an implementation of the Sea of Eratosthenes, which took some practice to be able to pronounce as smoothly as I just pronounced it. And we could go and start using this and keep switching back and forth from the Jupyter notebook into the primes library and develop our library this way. So we're developing a test suite, we're developing functions, and we're able to keep using those functions that we just made inside the Jupyter notebook. And so this is sort of the workflow I'm encouraging, and hopefully Callisto helps you smoothly transition back and forth from those 2. Great. So here again are the 2 lines, and here are some resources. I'm happy to take some questions.